Hi, this is Balakumar from Chennai. I want to continue my topic on FFT, but this time algorithm we will see. For lack of time means December 11, 2017. JNTU students have exam, DSP exam coming Monday. So I am taking it directly from the notes. Don't mind. First I will take in English and then in the later video I will take in Tamil and Telugu. Okay, kindly adjust. But later in future I will work out and show you. Thank you. Decimation, that is endpoint DFT using decimation in time radix to FFT. That is, this is DIT FFT radix to endpoint DFT algorithm. Clear? So as you know, x of k formula is given as sigma n equal to 0 to n minus 1 x of n e power minus j 2 pi k by capital N into small n, where k varies from 0, 1, 2 till n minus 1. We'll keep this as equation number 1. Fine. Now, what is the idea? What is decimation in time first of all? Decimation in time is nothing but we are going to decimate the time domain sequences into frequency domain sequences. X of n we are going to decimate. Decimate means it is breaking. So we are going to break the time domain sequence, which is nothing but x of n. How we are going to decimate? We are going to break it or decimate x of n into two sequences of n by 2 samples, f1 of n and f2 of n. How we are going to decimate? One is even, another is odd. Fine. Okay. So let f1 of n is equal to x of 2n, which is even sequence. f2 of n equal to x of 2n plus 1, which is odd sequence, for n equal to 0 to capital N by 2 minus 1. Because n, total number of samples n, we are going to decimate 2 halves. Therefore it is 0 to n by 2 minus 1. Okay. So equation 1, how it can be written? So we are decimating into even sequence. X of k is equal to 1 is even sequence. So the formula k n becomes k to n, and this is odd sequence, x of 2n plus 1 k 2n plus 1. And what is the limit? 0 to n by 2 minus 1, both for even and odd. Now we are going to deal with this phase factor or twiddle factor separately, and then we are going to again substitute this in equation number 2. So how we are going to deal this? W n power k 2n. Wn is nothing but the phase factor formula is nothing but e power minus j 2 pi kn by n. Instead of small n we have 2n, therefore k 2n by capital N. Fine. And this 2, when you bring it down, it becomes n by 2. And this again can be written in terms of phase factor w n by 2 power kn. Okay. The next one, w n power k 2n plus 1. This again e power minus j 2 pi k 2n plus 1 by n. So this is a power m plus n, we can write it as a power m into a power n. So this one is nothing but k 2n by n into k by n. K 2n by n already we saw here, we can write it as kn by n by 2. Next one is w n power k, that remains as it is. Fine. Now, so substitute these two in equation number 2. It can be modified as sigma, the limit same. Instead of x of 2n, already we told, instead of x of 2n we are assuming it as f1 of n. So we can write this as f1 of n w n by 2 power kn, and then this is f2 of n w n by 2 power kn and w n power k. Equation number 3. Now by the definition of n by 2 point DFT of f1 of n f2 of n, we have f1 of k is equal to sigma n equal to 0 to n by 2 minus 1 f1 of n w n by 2 power kn. Similarly, f2 of k means we will have f2 of n. This is the definition for f1 of k and f2 of k for n by 2 point DFT. If it is n point DFT, already we saw here, n point DFT means it is nothing but 0 to n minus 1. So n by 2 point DFT means it is 0 to n by 2 minus 1. So substitute this and this in equation number 3. We can replace. So this becomes f1 of k and this becomes f2 of k. Extra one multiplication factor is wn power k. So equation 3 becomes now x of k is equal to f1 of k plus wn power k f2 of k. We can assume it as equation number 4. This is one decimation. We know the DFT of a sequence is periodic with period given by the number of points of DFT. That is one property which says x of k plus n equal to x of k. It is just periodic. Now we are not dealing with properties, just the algorithm. That can also be proved. Therefore f1 of k and f2 of k will be periodic with period n by 2. Therefore f1 of k plus n by 2 is equal to f1 of k f2 of k plus n by 2 is equal to f2 of k, and even the phase factor we can simplify it as wn power k plus n by 2. When you solve it, we get minus wn power k. Okay, now next one. For example, if you take n equal to 8, k is equal to 0 to n minus 1, right? So capital N minus 1 means 8 minus 1, it is 7. So we got the equation x of k is equal to f1 of k plus wn power k, f2 of k. Now if substitute k is equal to 0, we get k is equal to 0, 0, 0. Now k is equal to 1 means we get x of 1 equal to f1 of 1 instead of k, wn power 1, f2 of n. And then k is equal to 3, 1, 2, 3. 3 means this will be 3, 3, 3, 3. Substitute from 0 to 7, we get this. Here I am not writing, but in the exam you write everything. From 0 to 7, write everything. Don't be lazy. Okay? Fine. Just for understanding purpose and shortened notes, I am writing like this. Okay? Now, what is f1 of 4? Just now we saw the property. f1 of k plus n by 2 is equal to f1 of k. Therefore, f1 of 4 will be what? f1 of 0. Because n by 2 means capital N is equal to 8 means 8 by 2 is equal to 4. So, f1 of k plus 4 is equal to f1 of k. Now, so this becomes f1 of 4 becomes f1 of 0, f2 of 4 becomes f2 of 0. And even this wn power 4, here because of this property it becomes w minus wn power 0. Fine. Okay, so come here. Again, so 4 becomes 0, 5 becomes 1, 6 becomes 2, and 7 becomes 3. So the last 4 equations, in simple terms, replace the first 4 equations. Instead of plus, you put minus. There ends the matter. Okay, don't get confused, don't get complicated. It is as simple as that. Fine. Now, similarly, we can repeat the process for each of the sequences of f1 of n and f2 of n. Thus, f1 of n would result in 2 n by 4 point sequences, and f2 of n would result in another 2 n by 4 point sequences. Clear? Now, again we are going to decimate n by 4 point sequences of f1 of n. Let it be v11 of n, and f2 of n be v12. f1 of n it is be v11 and v12, and f2 of n it becomes v21 and v22. Just a simple notation. Okay. Now, therefore, again first we decimated x of n as f1 and f2. Now we are going to decimate f1 as v11 and v12, and f2 as v21 and v22. Clear? Therefore, if that is 0 to n by 2 minus 1, this will be 0 to n by 4 minus 1. Okay. Now, therefore, what is v11 of k? v1 of k is equal to n by 4 point DFT of v11 of n, and similarly v12 of k and v21 of k and v22 of k, n by 4 point DFT of v22 of n. Okay. Then, like earlier analysis, what do you mean by earlier analysis? Here we did one analysis, no? This point. This analysis, if you do again, it is simple. Replace 2 by 4 and replace 1 by 2. That's it. We get it as f1 of k is equal to v11 of k plus wn by 2 power k v12 of k, and f2 of k is equal to v21 of k plus wn by 2 power k v22 of k, where k is equal to 0 to n by 2 minus 1. Later in 8-point DFT algorithm, DIT FFT, we are going to replace n by 2 as 4 and n as 8. That's it. Okay. Hence, the n by 2 point DFTs are obtained from the results of n by 4 point DFTs. Thus, the decimation of the data sequence can be repeated again and again until the resulting sequences are reduced to 2-point sequences. This is n-point DFT algorithm. Now, straight away we will go for 8-point DFT. 8-point DFT. Okay. 8-point DFT. Very important using concerning analytic point of view. But JNTU, they ask both the n-point and 8-point. Clear? So this is 8-point DFT by radix to DIT FFT algorithm. This becomes simpler because we are going to use the results of n-point DFT here in this 8-point DFT. That's it. This is the definition for DIT, decimation in time. As I told you before, the frequency domain sequences are obtained by decimation of time domain sequences. Okay, so first one is decimation or nothing but breaking of time domain. See how we are going to break it. X of n as f1 and f2, because you're dealing with 8 point. This is 4 point and 4 point, 0 to 3, because 8 is given 2 halves, n equal to 0 to 3. And this is f1 of n. Again we are going to decimate as v11 and v12. One is even, another is odd. And f2 as v21 and v22. One is even, another is odd. Since it is a 2 point sequence, each n equal to 0 and 1. Now what is FFT concept actually? N equal to r power m, where n is the endpoint DFT, r is the radix. Here radix is equal to 2 and m is the number of stages of computation. Here n equal to 8. Therefore if n equal to 8, you have substitute here. R is equal to radix 2 means 2 power m, where m is equal to 3, because 2 power 3 is only 8. So m equal to 3, we have 3 stages of computation: 2 point DFT, 4 point DFT and 8 point DFT. Fine. So what is the first stage of computation? Vxy of k, 2 point DFT. 2 is nothing but, as we see here, 1 1 1 2 2 1 2 2. First, in general, if you write Vxy of k, sigma n equal to 0 and 1, Vxy of n, capital V write like this, small v write like this with a stroke. We would have studied in LKG, UKG. Fine. W2 power kn, where k is equal to 0 and 1, because it is 2 point. Here xy is equal to 1 1 1 2 2 1 and 2 2. Okay. Now if you come here, first we will keep xy as 1 1, v11 of k. So replace xy as 1 1. Now our k is equal to 0 and 1. Here we have two variables. One is k is equal to 0 to 1, another is n equal to 0 and 1. Better first we substitute k. When k is equal to 0, when you put k is equal to 0, this becomes w, k 0 into n, it becomes 0. W2 power 0 is 1, phase factor. Now something into 1 is nothing but something. Now you substitute n. So when you substitute n, this becomes the v11 of 0 plus v11 of 1. Already we saw here what is v11 of 0. v11 of 0, when you put n equal to 0, this becomes f1 of 0. Again, what is f1 of 0? When you put n equal to 0, this becomes x of 0. Next is v11 of 1, if you see. So what is v11 of 1? f1 of 2. When you put f1 of 2 here, n equal to 2 means it becomes x of 4. Clear? Why to flip the pages again and again? I told you. Instead of that, I have seen once for all. Clear? So one is v11 of 0, just now I told you it is f1 of 0. v11 of 1 is f1 of 2. f1 of 0 is again x of 0. f1 of 2 again x of 4. Just now we saw. Now first k is equal to 0 is over. Therefore v11 of 0 is x of 0 plus x of 4. That is why in the algorithm we have, when you see the problem, a plus b. One is x of 0, another comes x of 4. Okay. Next is k is equal to 1. v11 of 1. Put k is equal to 1 here. This is the main equation. Put k is equal to 1. 1 into n, n. Okay. Now put n equal to 0. This is 0, 0. Next again 1, 1. Okay. So the w2 power 0 is 1. w2 power 1, when you evaluate, e power minus j2 pi kn by n. Kn is 1. Capital N is 2. So this is 2 to cancel. E power minus j pi, answer is 1. So w2 power 1, the value is minus 1. This again can be written as minus 1 into w2 power 0. Okay. Just for algorithm's sake, I am writing this. So minus w2 power 0. So v11 of 0, we got it as x of 0. Then this is x of 4. So one is a plus b, another is a minus b. Similarly, we can solve for v12 of k. Where and all xy is there, you put 1 2. Similar derivation like this. So first we got 0 plus 4. Next we will get 2 plus 6. That you should derive it. Okay, algorithm, you derive for v11 and v12. No need to derive for v21 and v22. Just you can write similarly. So this will be 2 plus 6 and 2 minus 6. Anyone guess what will be for v21? v21 will be x of v21. v21 will be, I think I wrote it here itself, sorry. Okay, so v21 of k is equal to, one is v2 of 0 is x of 1 plus x of 5, and v21 of 1 will be x of 1 minus x of 5 into w2 power 0. No need to derive. Don't write this in the exam. Just for understanding sake I wrote. Okay. v22 of 0. Next is xy is equal to 2 to x of 3 plus x of 7. Then v22 of 1 will be x of 3 minus x of 7. And here